Hello, friends. Good morning to all of you. Today I am here with one another video regarding the materials for the pipes and valves. Basically, this is one of the most frequently asked question in the MND exams, especially the orals point of view, that what are the different materials used for the pipelines and the valves. So we have onboard ship separate types of the pipelines, pumping systems like the seawater pipelines and pumping system, freshwater pipelines, pumping system. Then we have the fuel oil, lube oil, boiler feed water, steam lines, control air lines. So many things are there, fire lines. So what I'm going to discuss today, that suitable material as per the requirement, what is to be utilized. Here you can see materials basically used in the pumping system and valves or the piping system must be compatible with the fluid which is conveyed to it. That means the fluid which is passing through it, the pipeline materials should be compatible. Otherwise, on board ship, we have seen so many problems related to the corrosion and related to that pitting and all. So this is going to destroy the complete pipeline. So most commonly used material is the carbon steel which is being utilized. But they can also be made from the stainless steel. But these things are not found on board generally until unless some specialization is there or some specialized ships and all, like some chemical tanker. Okay. So what is the benefit of stainless steel? Corrosion free and if the cryogenic needs, basically when the temperature is very less. Chrome molybdenum steel for high heat resistance, basically in the boiler pipelines, feed water pipelines, and steam lines. Okay. Cast iron, copper, brass, bronze, copper, nickel, and sometimes plastics also, that is your for pipeline inside the accommodation for the water supply and all. But generally, it is also metal. So to prevent the corrosion and galvanic attack. So these are some of the materials which is being utilized for the piping system. So we will see basically core structural design on deck. Okay, so when we talk about deck, generally grade B carbon steel are commonly used on board, like for the basically on board on deck, especially on steam, condensate oil and air system which is being passing through the deck. So this is grade B carbon steel. Materials joining in a piping system must be similar to avoid the galvanic action. In my previous video, I have already explained to you guys regarding the corrosion part and galvanic corrosion, bimetallic corrosion. So basically, when we are joining the piping system, materials used should be of such a way that galvanic corrosion should not happen. Mixing steel and brass fittings in seawater line would result to the accelerated galvanic corrosion of the steel. It is acting like a sacrificial anode. Basically, we can see this one by seeing the galvanic series. So that also I have described in my previous video regarding corrosion part. Okay. The less attractive material are more resistant to the galvanic corrosion. That is your noble metal. So in galvanic series, if you see the material which is in the bottom part, so they are acting as a cathode, and the material which is on top part, they are acting as a anode, and they are getting sacrificed. So that we have to see, and accordingly we have to use the material. Basically, ship's piping is grouped into three categories, three major categories. It is based on the class as per the technical requirement. So as you can see over here, this is something which is class 1 pipes, and they have to comply with the most stringent requirement. What are these pipelines? Fuel oil pipelines. Approximately pressure up to 16 bar, means 8 to 16 bar, and approximately temperature 150 degrees centigrade. And some of the steam pipes where the temperature exceeds 300 degrees centigrade. So this is something which is most strict and stringent requirement, and that comes under your class 1 pipes. The class 2 pipes fall between these two rule requirement like your class 1 and class 3. We have class 3 pipes also. Class 3, 5, this is something which is the lowest requirement. Pressure approximately below 7 bar and temperature below 60 degrees centigrade. So class 1 is on top and class 3 is on the lowest requirement. We will see how the material utilized for the separate piping system. Different pipeline system like seawater pipeline, galvanized mild steel or plastic coated pipes, rubber coated pipes. In fact, I have seen the piping and flanges are completely encapsulated in plastic. This protects both from inside and outside. GRP is also there, utilized glass reinforced plastic for the ballast lines and all. That also I have seen, and it is going to protect the pipeline. Ballast system, which you can see, maybe also galvanized plastic coated steel piping also will be used, and it is having long lasting. The life is more. Cooling water system. This unit distilled water to be used for the steel piping. Where it is used, water must be treated to protect the pipeline from corrosion. So anyway, cooling waters, whatever is either main engine cooling water or jacket cooling water for the generators also, these water treatments are going on continuously to protect the pipeline and including the system also. So these are freshwater cooling part. Freshwater cooling pipes are generally made of the mild steel. Most of the pipelines are made up of mild steel, but some specializations are also there. Like we have seen in the class 1, like you have the fuel pipelines and the steam pipelines. Fuel oil transfer pipes, mild steel. Lubricating oil system, they are also mild steel pipelines in the engine. Domestic freshwater system, they may use plastic piping for supply lines to the various location of the accommodation. But generally, copper system is being used. Connections from the supply line to the taps and faucets are often made of the copper tubings that we have seen. Hot water serving pipelines, material used for UPVC or stainless steel, because we are utilizing the hot water 50, 60 degrees centigrade. Fire mains, mild steel piping fitted with the hydrants, and where we are using basically the salt water for the manual firefighting. So firefighting pipelines are mild steel and on accommodation outside or the deck, or you can say engine room also. So they are having the mild steel. Okay. Inert gas pipings, large diameter, low pressure mild steel with smaller diameter branch. Here also we have the sulfuric acid corrosion because of the soot deposition, because of the uncarbon particles, unburnt carbon particles also present in that, and sulfurous and sulfuric acid formation is there, and you can see the corrosion of these pipelines on deck. CO2 piping, a small bore pipeline, hot galvanized mild steel, and designed to withstand the surge loads that may occur during the release of the CO2. So it can withstand high pressure. That pipeline should be there, and it can take the loads. So galvanized mild steel, you can see that galvanized mild steel is utilized. Next is your air and sounding pipes, constructed of mostly mild steel part. Okay. Cargo piping in tankers, mild steel protected by rusting for the external painting, and also basically we have to protect these pipelines so that the smooth flow of the fluid should be there. Either we talk about cargo, either we talk about the this is something which is your fire main and air pipeline or steam pipeline, whatever is utilized on deck. So we have to protect that. External painting and maintenance of the pipelines are required. So mild steel is to be protected by the external painting. Stainless steel piping invariably used for the stainless steel tanks. Mostly it is for the chemical tanker which is being utilized, where we have to use the chemicals, and chemicals is having the highly corrosive in nature. Okay, so that also you have to see. Here we can see this is the chart. In this one, first column talks about your service, where it is utilized. Second is your common application, and this is the US Navy application and percentage of the materials, separate metals which is being utilized. Seawater, dry fire main, bilge ballast system, The carbon steel, galvanized steel. When we talk about this, the 90% copper, 10% nickel, or sometimes GRP also. Seawater flooded, the 90% copper, 10% nickel, GRP. Okay, so same over here also. Freshwater cooling, carbon steel, GRP. GRP means grass reinforced plastic. Stainless steel 90 to 10 copper nickel. Okay. Potable water, copper, sometimes PVC, sometimes GRP. Here also copper and GRP. Chilled water, copper, PVC, GRP 90% copper, 10% nickel, copper and GRP is utilized. Okay, in this slide, I am going to explain about the continuation of the service, commercial application and US Navy application. For the lube oil pipeline and pumping system, the carbon steel is being utilized, or sometimes stainless steel or galvanized steel is also being utilized. For the fuel, we have seen earlier, it's a class 1 system, the diesel and residual fuel, which is being utilized. So high temperature, high pressure carbon steel is the first choice, and this is being utilized on the mostly on board ship. Cargo oil, carbon steel, and sometimes ductile iron, because this is also in corrosive in nature. So this is being utilized. A steam pipeline, again, it's a class 1 type. So here the alloy steel, carbon steel to be maintained. The scheduling is also, that means the thickness of the pipeline also is more. Okay. Condensate system, here again the temperature and pressure both will be there. So carbon steel, or sometimes if it is a small pipeline, then the copper is also being utilized. In US Navy application also the carbon steel is being utilized. Okay. In continuation, again here you can see the feed water, like the boiler feed water pipe, carbon steel in both the cases you can see here. The plumbing drains and all freshwater drain system and also carbon steel, sometimes PVC or GRP, and here also it is being utilized as a copper. Here seawater plumbing drains, so carbon steel, PVC and GRP, 90% copper and 10% nickel. So wherever we are utilizing this seawater, then you will see this type of things in the US Navy application on board ship. Compressed air, here carbon steel, copper pipelines are also being utilized. Here the 90% copper, 10% nickel, and sometimes a stainless steel is also being utilized. Okay. Hydraulic pipelines. So carbon steel, stainless steel, and here the hydraulic pipelines, you can observe that the thickness is more because they have to sustain the large pressure. Okay. So schedule 80 pipelines are also being utilized. Carbon steel, stainless steel, sometimes copper, 90% copper and 10% nickel as per the new US Navy application. Here you can see again the hydraulic system, which I have explained earlier also in this chart. Next is your fire extinguishing system, carbon steel and copper carbon steel, which is utilized for fire extinguishing. Like you have the CO2 and all, foam and all utilizing this. Foam extinguishing carbon steel, 90% copper and all of 10% nickel. Halons, basically it is banned now. So earlier the carbon steel, galvanized steel, 90% copper, 10% nickel and stainless steel is being utilized. Cryogenic fluids like energy, which is being stored at minus 162 degrees centigrade. So stainless steel is being utilized to sustain the cryogenic effect of the fluids. Okay. So I have tried my level best to explain you guys regarding the various pipelines and pumping system on board ship and the materials utilized for making those pipelines and pumping system. In the last 2 3 slides, I have given you the list also, or the chart also, where it is being completely summarized. You can view this one and remember that what type of material which is being utilized for the pump and pumping system. Further, more technical details about pipeline, pumping system and valves, I'm making those things. It is in my pipeline. So once it will be ready, I will publish that video also. So thank you for watching this one, and I hope this is going to help you for preparing and clearing your exams. Thank you.